All right, guys, I'm going to try to get through the second part a little bit faster now that we've done some example problems. You should be kind of getting the hang of it, and I can always come around and answer questions as well. So, the next thing we're going to do, those were our mole to particles, right? If I asked you how many oxygen particles are in the air. Now I'm going to ask you, for instance, I don't know, how many grams is how many moles are in 26 grams of hydrogen, right? Something like that. If I want grams of something, this is usually with a solid metal that we use in chemistry. So, again, sorry, going to try to go through this one a little faster. So, if you're doing mole to mass relationships, or if you want grams of something, you're going to use the following conversion factors. Go ahead and write this down. 1 mole over the molar mass, or the molar mass over 1 mole, right? So you're going to have to calculate the molar mass of the substance first. Beautiful. Here's my example problem. How many grams are in 9.45 moles of N2O3? So what is the known information, right? The problem gives me 9.45 moles of N2O3. However, my unknown is my mass. I want grams. How many grams are there of N2O3? So step 1, the first thing I'm going to do, I'm going to calculate the molar mass of N2O3. So remember how to do this. Nitrogen, we have 2 of them, and its mass is 14. So I'm going to go 2 times 14 equals 28. I have 3 oxygens. They each have a mass of 16. So after I calculate that, I have 48 grams. When I add both of those together, I get 76 grams. So this is my molar mass. Beautiful. So to solve this problem, it's already there, but to solve this problem, we're going to take my known information and put it in the top left, always. So I'm going to put 9.45 moles in the top left. Now, I'm trying to cancel out moles. So the next thing I do, I need to multiply, but I would put, if I'm trying to cancel out moles, I have moles at the bottom, and that is equal to the molar mass of N2O3. So I can put 1 mole over the molar mass of N2O3, which is 76 grams, and that will give me 718.2 grams of N2O3. Wonderful. Oh man. Sorry guys, I didn't make these to where the answers didn't come up already. That was my fault. But anyways, please follow along. You are going to need to know how to do this on your test. So if you copy everything down now and don't really care to listen to the explanation, unless you know what you're doing, it's going to be a bad test. So make sure you're paying attention. So find the number of moles in 92.2 grams of Fe2O3. So what's my known information? It is 92.2 grams. The unknown information, right, is the thing I'm trying to get to, is going to be moles of Fe2O3. So again, step 1, find the molar mass of Fe2O3. I have 2 irons, both with 56 grams, so that's going to be 112. And I have 3 oxygens, both, all of them are 16 grams, so we have 48 total grams of oxygen. When I add these together, I'm going to get 160 grams. Step 2, we're going to solve, right? So my known is going to go in my top left corner. My known in this problem is 92.2 grams, so I'm going to put that in the corner. So my next question is, I'm trying to cancel grams. So does grams have to go at the top or the bottom? Grams needs to go at the top or the bottom. Because I have grams up top, I need grams at the bottom for them to cancel out. And I put moles at the top. When I do this math, I do 92.2 times 1. Then I would divide all of that by 160 grams. That will give me 0.576 moles of Fe2O3. Wonderful. Don't worry about the 1 under the 92.2. It is unnecessary. All right, here we go. All right, a couple more example problems. Find the mass of 2.1 times 10 to the 24th molecules of NaHCO3. This is carbonic acid with sodium. Neat. Okay, anyways, so what you're gonna do, write down the known, write down my unknown. My known is 2.1 times 10 to the 24th molecules. What is my unknown? It's the mass, right? Beautiful. So always start by putting my known, my 2.1 times 10 to the 24th, my known molecules in the top left corner. So that is what we are going to do first. All right, now we don't want molecules, right? We want mass, which is a little bit different because I can't just go straight from molecules to mass, right? We don't have a conversion for that. So what can I do? I can get to moles and then I can go from moles to mass. So if I'm going from molecules to moles first, let's do that. If I'm going from molecules to moles first, based on this problem, do I need to put molecules at the bottom right now or at the top? The correct answer is the bottom. I want molecules at the bottom that equal 1 mole so that I can cancel out my molecules, right? So if you guys remember, 6.02 times 10 to the 23rd molecules is equal to 1 mole. So I can put 6.02 times 10 to the 23rd at the bottom, and I can put 1 mole at the top. All right, now that I'm at moles, I didn't want molecules to moles, right? I wanted molecules to mass. So since my unknown is mass, now I'm going from moles to mass. So how can I do that? Well, I first, let's see. Do I need moles at the what do I want? Let me phrase it like this. My unknown is mass, right? So I want mass at the top right-hand corner. What do I need to put on the bottom to cancel out moles? Moles, right? So 1 mole, I can put 1 mole at the bottom. What does 1 mole equal? The molar mass, right? So 1 mole is equal to the molar mass of NaHCO3. So I would need to calculate the molar mass of NaHCO3. So go ahead and try that. Just at the top of my head, I think sodium's molar mass is about 23, hydrogen's is 1, carbon's is 12, oxygen is 16. That is off the top of my head. So if that is wrong, please check your periodic tables and correct me. But it looks like I got about 84 grams. So go do the math yourself. Make sure this is correct. Is always a smart thing to do because you guys are all very intelligent and I have been corrected before by you guys, which honestly just makes me so proud. So I would have moles at the bottom, and I have grams up top so that moles cancel and I'm left with grams, which is the mass. So I would get 293.02 grams of NaHCO3. Now, we talked about significant figures at the beginning of the year. I'm not too incredibly worried about them right now. Give me like 1 or 2 places. Give me 2 places after the decimal point. All right, we're going to move on. Awesome. This is the last one, guys. The last conversion we need to remember. So we have particles to moles, right? We have mass to moles, and now we have volume to moles because we can still measure things in volume in chemistry. So for instance, if I have a gas tank, this is mostly with gas tanks. Let's see. For a lot of experiments, for science or organic chemistry experiments, you use a nitrogen tank. For instance, there are particles and elements that when exposed to the air will either react with the air and form something completely new so you can't use it anymore, or even some elements explode when they're exposed to oxygen, which is not ideal when you're trying to, mix the solution together. You don't want your solid exploding on you before you get the chance to do it, right? So, not a lot of things, but we do not want a lot of things exposed to air. However, we can expose things to nitrogen gas. The reason being is because nitrogen has those strong triple bonds. They aren't going to react with anything. If I have two nitrogens next to each other, they are not reacting with my solid that I'm trying to get to react. So we usually use nitrogen gas. And I fill up a gas tank with this nitrogen gas, right? And I want to know the volume of nitrogen gas in my gas tank. So this is what this would be used for. So the volume of gas varies with a change in temperature or pressure. So volume does change based on your temperature or pressure. So we usually say things are measured at standard temperature and pressure, or STP. Everything you need to write down is in green, just a heads up. STP. So STP is at 0 degrees Celsius or 32 degrees Fahrenheit and at 1 atmosphere of pressure, but we will talk about that more later. All you need to really know right now is that 1 mole of gas is equal to 22.4 liters. So if I have 1 liter of nitrogen, if I have 22.4 liters of nitrogen, I have 1 mole of nitrogen. If I have 22.4 liters of hydrogen, I have 1 mole of hydrogen. So it's not like our molar mass that changes. This always stays the same. So my conversion factors are 1 mole divided by 22.4 or 22.4 liters divided by 1 mole. All right, here's your example problem. Determine the volume in liters if 0.6 moles of SO2 gas at STP. All right, so what is our known value? It is 0.6 moles. And what is our unknown value? You should have the volume written down. Our unknown, what we're trying to find is the volume. Our known is 0.6 moles because that's what was given to me in the problem. All right, so we're going to start with the known and then use the conversion factors to solve for the unknown, just like we've been doing. So you're going to start with your known, top left corner. You're going to have 0.6 moles at your top left corner. Go ahead and write that down. Now, your moles are at your top left, right? And I want to get to liters. Liters, my unknown has to be at the very top right-hand corner. So, if I have moles right here up top, do I need moles at the bottom or moles at the top? Correct answer is I want moles at the bottom so that moles cancel out. And we do know that 1 mole equals 22.4 liters. So I want moles at the bottom, 22.4 at the top. This will give me, when I do my math, I'll do 0.60 times 22.4 divided by 1. That will give me 13.44 liters of SO2, which is the name of it. Anybody? Sulfite. Very good, children. Very good. All right. That is all the conversion factors you need to know. You need to know the mass to mole. You need to know the particles to mole, and you need to know volume to mole conversion factors. You need to know all of those. Please do the rest of your practice problems on your sheet. We will be doing a lot of practice problems on this, and it may seem painful at the moment, but you guys will thank me when you get really, really good grades on this test, because this is an incredibly challenging unit, and it is an incredibly challenging unit after this one as well. But I promise, if you use PAL, if you understand how to use PAL, this makes your life a lot easier now and in the future. We already talked about percent composition, so I will not be going over those slides. Sweet. You guys are good for this video. Go ahead and start your lab, work on your lab, finish your lab. All of this, the notes and everything, and the lab are due on Friday before you leave. So feel free to work on those for the week. And again,